Hi, today we are going to discuss all the exam questions from Maths for Year 11. Let's get started. Number 1. To solve number 1, we need to know the differences between underlined inequality and when there is no underline next to the inequality. Underlined inequality means that the endpoint is included and no underline next to inequality sign means that the endpoint is not included. Now let's represent the solutions on the number line. 1 and 8. We need to show 1 with the closed circle because 1 is included but 8 is not included, it's open circle. Now we need the numbers in between 1 and 8. The set of solutions will be from 1 till 8 but 8 is not included. 7. Now what is the number of natural solutions of the given inequality? We must count them 1, 2, 3, 4, 5, 6, 7. The correct answer is 7. Number 2. In number 2 we are given simultaneous equations. We can solve this either with elimination method or with replacing. But I prefer the second method. What we are going to do in here, we just need first to copy the question. 2x equals 6y plus 3x equals 14. Now, let's have a look at the first equation. We can say that x is equal to 3. Now, we can substitute the value of x into the second equation. We will get y plus 3 times 3 equals 14. Now, all we need to do is just solve the second equation. Y plus 9 equals 14. Y equals 14 minus 9. 14 minus 9 is going to be 6. Sorry, it's going to be 5. Now, the question asks why, that's 5 is the correct answer. Number 3. Number 3 is about permutation. To solve this question, we need to know the formula of permutation, k elements out of n. It's equal to n factorial over n minus k factorial. And what is n factorial? It's the product of first n numbers. Now, let's apply this formula. P 5 out of 5 will be 5 factorial over 5 minus 5 factorial. Minus x equals 7 factorial over 7 minus 2 factorial. Now, let's simplify. 5 minus 5 factorial. Let's remind one more thing that 0 factorial is equal to 1. Now, 5 factorial over 0 factorial minus x equals 7 factorial over 5 factorial. Since 0 factorial is 1, we will just write 5 factorial minus x is equal to. Now, 7 factorial. 7 factorial can be shown as 5 factorial multiplied by 6 multiplied by 7. They are same things. So it will be 5 factorial 6, 7 over 5 factorial. Now we will cancel them. 5 factorial is itself 1 times 2 times 3 times 4 times 5, which is 120. Now let's write 120 minus x is equal to 6 times 7 is 42. X is going to be 120 minus 42. So it's equal to 78. The correct answer is 78. Number 4. Number 4 is also about simultaneous equations, but here we don't necessarily need to find separate solutions. Instead, we need to find the value of a squared minus b squared. In order to solve these questions, we need to know the formulas a squared minus b squared equals. Also, we need to know a plus b cubed formula, a minus b cubed. These are called polynomial identities. A minus b, a plus b. A plus b cubed will be a cubed plus 3a squared b plus 3ab squared plus b cubed. A minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. Now, taking all these polynomial identities into consideration, we will write their sum. Let's sum up the equations. A cubed plus b cubed plus 3ab squared plus 3a squared b is equal to 36 plus 28. Now, what we see here is the same expression with the second polynomial identity. Instead of the expression here, we will write a plus b cubed equals 36 plus 28 is equal to 64. From this, we can find that a plus b is 4 because 4 cubed is 64. Now, with the same method, we will subtract the equations. A cubed minus b cubed plus 3ab squared minus 3a squared b equals 36 minus 28. Now, comparing these these expressions, we will see that they are equal. Instead of this entire expression, we can write a minus b cubed is equal to 36 minus 28 is just 8. We know that 8 is 2 cubed. Therefore, a minus b will be 2. Now, since we know a plus b and a minus b, we can apply a squared minus b squared here. It's a minus b, a plus b. And 2 multiplied by a plus b is 4. That's just 8. The correct answer is 8. Number 5. Number 5 is about logarithms. In order to solve this question, we need to know some formulas of logarithm. First of all, we need to know that if we have logarithm base a to the power of m of b to the power of n, this is going to be n over m multiplied by log base a of b. The second formula that we will need is to know that when a and b are reciprocal numbers, that is to say that a multiplied by b is equal to 1. Then logarithm base a of b is equal to -1. And one more formula that we will need is to know logarithm base a of a is just equal to 1. Now let's look at the question and try to simplify. Here we have 9 logarithm 27 is going to be 3 cubed. It's always useful to show all the numbers as a powers. So 3 multiplied by 3 squared is going to be 3 to the power 1 over 2 plus log 2 plus square root of 3, 2 minus square root of 3. Now we are getting 9 to the power of that 3. The power 3 will be in front of log. It will be 1 over 3 log 3, and in here we will get 3 to the power of 3 over 2 plus, and what will we do with these numbers? First, we must check that if they are reciprocal. 2 plus square root of 3 multiplied by 2 minus square root of 3 is going to be 4 minus 3, which is 1. Now, we will conclude that they are reciprocal numbers. Therefore, their log will be -1 is equal to. Let's simplify the first term. This is going to be in the coefficient 3 over 2 multiplied by log 3 and 3 minus 1 is equal to. Let's simplify 3's. We will get 9 to the power 1 over 2. That's going to be 1. Multiplied by 1 minus 1. So we have just 9 to the power 1 over 2. That means that square root of 9 minus 1 is going to be 3 minus 1. That's 2. The correct answer is 2. Number 6. Number 6 is about trigonometry. Here we need to know the value of sine pi over 2. Sine pi over 2 is just sine 90 degrees. That's 1. And then we need to be able to solve some equations, trigonometric equations. Before that, let's write the value of sine pi over 2 in the equation. So that's going to be 1. Now let's have a look at this general form when cosine x is equal to 1. Cosine x represents the horizontal axis, and for horizontal axis it's unicircle. In unicircle we are looking at this point. In order to get that one, we need to we need to have full turns. So full turn is 2 pi. After one full turn, first the point is on 0 degrees, then it turns, it's 2 pi, then 2 times 2 pi, it means 2 full turns, and 3 times 2 pi, 3 full turns, and so on. Therefore, the solution of this equation will be x equals 2 pi multiplied by k. Here, k's are integer numbers. Now, in this question will be pi plus x is equal to 2 pi multiplied by k, and x is equal to negative pi plus 2 pi multiplied by k. Now, we are looking for the answers, but we don't see this answer. Let's look at this full turn, and when we add negative pi, it means that we go back along the semicircle and we reach to this point. It's negative pi plus 2 pi multiplied by k. What about pi plus 2 pi k? After full turn, we must go on along the circle and along the semicircle, and we will also reach to this point. Therefore, it doesn't matter if you choose negative pi over 2 pi, pi multiplied by k, or pi plus 2 pi multiplied by k. Therefore, the correct answer will be D. Number 7. In number 7, we must find the derivative of the function. That function is composite function. Y equals to 2 times tangent 6x. Let me write it once again. Y equals 2 multiplied by tangent 6x. Here we need to remind the formula of composite function. When we have y equals f of gx function, derivative of y with respect to x equals to derivative of f with respect to g multiplied by derivative of g with respect to x. Now, in this question, we see that our f function is equal to tangent gx, let's say, where gx is 6x. Now, in order to find the derivative of y, we will say that y, the same formula, y derivative with respect to x equals to tangent g of x with respect to gx multiplied by g of x derivative with respect to x. Now, what is happening here is we need to know that the derivative of tangent x is equal to 1 over cosine squared x. Now, for this question, we will write 1 over, let's not forget 2 here, we must multiply 2 by 2 here. Now, 2 multiplied by 1 over gx, so it will be cosine squared gx multiplied by derivative of gx, so we will write derivative of 6x is equal to 2 multiplied by cosine squared 6x multiplied by just 6, because we know that any constant multiplied by x derivative is just going to be the constant itself. So the answer is going to be 12 over cosine squared 6x. Number 8. 2 fair dice are rolled. Find the probability of getting a composite number on both dice. Here we need to know the formula of probability. Probability of event A happening is equal to number of favorable outcomes over number of total outcomes. Then let's look at the question. It says two fair dice are rolled. We know that on the die there are 6 faces and 6 numbers. So in each die we have numbers 1, 2, 3, 4, 5, and 6. Since we need to get a composite number on both of these dice, we need to find the probability of getting 4 or 6, because 4 and 6 are the only composite numbers in the dice. So this is for first die, and for the second dice the same event must happen, 4 or 6. Now they must happen at the same time. It means that they must like first and second must happen at the same time. So here we have keywords or and. Or stands for plus and stands for multiply. Therefore, the probability of getting 4 or 6 is 2 out of 6, because we have 2 favorable outcomes and in total 6 outcomes. And means multiply, and here we have the same 2 over 6. Now the answer is going to be 1 over 3 multiplied by 1 over 3, which is 1 over 9. The correct answer is 1 over 9. Number 9. Number 9 is about imaginary numbers. To solve number 9, we need to know the formula of absolute value, finding absolute value of imaginary number. Let's say we have imaginary number z equals a plus b multiplied by I. Now, the absolute value of z is going to be square root of a squared plus b squared. Now, in this question, we have imaginary number z equals a plus bi, and real part plus imaginary part. Real part means a plus imaginary part is b, is equal to 5. And real part, which is a, multiplied by imaginary part, which is b, equals to 4.5. We must find the absolute value of z. To solve this question, what we need, first let's write the formula one more time. It's going to be a squared plus b squared. But since we have two equations, we can call them simultaneous equations, but we don't need to solve simultaneous equations. We just need to find this expression. So it's going to be, let's write the formula, the shortcut for this. A squared plus b squared can be represented with a minus b squared. In order to get this value, we should add 2ab. Or we have another formula, a squared plus b squared is equal to a plus b squared minus 2ab. We have a plus b, therefore we are going to use a plus b this second. It will be square root of a plus b squared minus 2ab. It's equal to square root of 5 squared minus 2 times 4.5. It will be square root of 25 minus 9, and square root of 16 is just 4. The correct answer is 4. Number 10. Here we see geometric sequence. We are given b2 and b5. We need to find sum of first 5 terms. In order to solve this question, we need to know the sum formula, the sum of first n terms of the geometric sequence. It's going to be b1 q to the power of n minus 1 over q minus 1. Now, how to know q? If we have b2 and b5, or if we have two distinct terms, we can say q to the power of n minus k is equal to bn over bk. And we can easily find b1 after finding q. Let's find q. Since we have B2 is 14, B5 is 112, let's write what is needed as 5 is needed. Now we can write q to the power of 5 minus 2 is equal to b5 over b2 because we only have these two terms. Now q to the power of 3 is equal to 112 over 14. Q to the power of 3 is equal to 8 and q is going to be 2. Now if we know q b1 is going to be b2 over q, alright, and that will be 14 over 2, which is 7. How to find S5? It's b1. In the formula we write 7 q to the power of n. 2 to the power of n is 5 minus 1 over q minus 1, 2 minus 1. So 7 times 32 minus 1 will be 31 over 1. So 7 times 1 is 7, 21. 217 is correct answer. Number 11. Number 11 is just calculation problem. Note that here we will not use any calculator. Calculator is not allowed in this exam. So let's copy the question. 10 whole 47 over 60 minus 8 whole 1 over 5 minus 5 whole 2 over 3 multiplied by 5 over 8 is equal to. According to the order of operations, we will first calculate the brackets. 8 over 1 over 8 whole 1 over 5 minus 5 whole 2 over 3 is equal to. When we subtract fractions, we must equalize denominators. Common denominator for 5 and 3 is 15. We must multiply 5 by 3 and 1 by 3 is 3. Minus 5 whole 15, and here will be 5 times 2, which is 10. Now we cannot subtract 10 from 3, therefore we can reduce the whole part. It's going to be 7 whole. 15 over 15 plus 15 over 3 is going to be 15 over 18 minus 5 whole 10 over 15. Now we can subtract 18 and 10, no problem. Therefore first we will subtract the whole part. 7 minus 5 is 2 whole, and 18 minus 10 is 8 over 15. After this, let's copy the answer here. 2 whole 8 over 15 and multiply by 5 over 8. Now 2 whole 8 over 15 multiply. The second operation will be multiplication. When you multiply fraction, it's important to convert the mixed number into the improper fraction. So it's going to be 15 in denominator. 15 times 2 is 30 plus 8 is 38. Multiply by 5 over 8. Before multiplying 38 by 5, it's better to simplify 38 and 8 by 2. Is going to be 19 and 4. 5 and 5 by 5. We can write 5 and 5 divided by 5 is 1, 15 divided by 5 is 3. Now it's easy to multiply 19 by 1, which is 19, 3 by 4, which is 12. Let's write the answer here. 10 whole 47 over 60 minus. It's better to show 19 over 12 as a mixed number. It will be 1 whole 7 over 12. Now subtract 1 whole 7 over 12. As we see, again, we need to write the common denominator for these fractions. It's going to be 60. 47 over 60 minus 1 whole. We will multiply 12 by 5 in order to get 60, and 7 by 5 it's 35. So 10 minus 1 is 9. 47 minus 35 is going to be 12, and this is 60. It's going to be 9 whole 1 over 5 or 9.2. The correct answer is 9.2. Number 12. Number 12 is a pretty easy question. Here it says the total surface area is equal to 150 centimeters square. We are talking about cube. So what's the total surface area of cube? The formula is 6a squared, where a is an edge. So let me show cube. If the A is the edge of the cube, the surface area is 6 times A. And what is the area of one face? The area of one face, since it's cube, all the sides are equal, all the edges are equal. So the area of one face will be A squared. Now we know that 6A squared, the surface area of cube, 6A squared is 150 centimeters squared. Here A squared will be 150 divided by 6. We can cancel it by 3. A squared will be, here will be 250 over 2. A squared equals 25, and A is going to be, that's all, A is 25. No need to find A because we need the area of face. The correct answer is 25. Number 13. Number 13 is also about, it's also a calculation problem. We don't use any calculator. We need to use the properties of roots. Now, what we see here, we have 3 square root of 60 minus 10 square root of 0.6. When we have square root of a multiplied by b, we can separate them and write separate square roots. Square root of a multiplied by square root of b. And yes, that's only root property we will use here. Now, if we have 3 square root of 60, it's better. There are lots of ways, but I prefer to show 60 as a product of 4 and 15, and 0.6 is similar. That's why we can show it as product 15 multiplied by 0.04. Now, using them, we can write 3 multiplied by square root of 4 multiplied by square root of 5 minus 10 multiplied by square root of 15 multiplied by square root of 0.04. Now it's obvious that the square root of 4 is 2 square. I mean, it gives 2, and we have square root of 15 here, minus, and this is 10 multiplied by 0.2, because 0.2 times 0.2 is going to be 0.04, and square root of 15. Now, 6 times square root of 15 minus 2 times square root of 15 is just 4 times square root of 15. The correct answer is 4 times square root of 15. Number 14. Let's read number 14. In a right circular cone, the area of cross section is 12 cm squared and the volume is 12 pi cm cubed. Find the radius of the base. In order to solve this question, let's look what is the area of cross section. Here, cross section means the plane that cuts the cone perpendicular to its base and passes through the vertex of cone. So, what this cross section will create? That is basically a triangle. I shade this triangle to see clearly. Now, the area of triangle is 12 cm squared. First, let's remind what is the area of triangle. Area of triangle is 1/2 of base multiplied by height. Now, the volume is 12. What's the volume of cone? Volume of cone is 1/3 of area of base multiplied by height. These heights here in the picture will be same, so therefore let's denote it with height h. Now, what is given? Let's write them. Area of triangle is 12 cm squared, volume is 12 pi cm cubed. Find the radius of the base. We need to find the radius of the base. Now, what's volume? Let's write it once again. 1/3 area of base. Since the base is circle, what's the area of circle? Area of circle is pi r squared. R squared and multiply by height. Let's write for area of triangle 1/2. What's b here? The base is twice radius. As you see from the picture, That triangle is isosceles triangle. That's why height will be a median at the same times. Therefore, the base is twice radius. So it will be 2 radius multiplied by height. This is the area of triangle. Now, instead of these letters, let's write their values. Area of triangle is 12. Volume of cone is 12 pi. Let's simplify and solve simultaneous equations. First, we see that we can cancel 2's, then we can cancel pi's. Let's cross multiply. 12 multiplied by 3 is 36. R squared h equals 36, and what's happening here, r multiplied by h is 12. Now here we don't need to find r and h separately. We just can write r squared multiplied by h as r multiplied by h. So since we know r multiplied by h is 12, we will multiply r by 12, which is 36. Now r is going to be 36 divided by 12, which is 3. So the correct answer is 3. Number 15. Number 15 is about logarithm. Now, how to solve this logarithm? First of all, we need to know that a to the power of log base a of b is equal to b. Next, we need to know how to solve this equation. Log base a of b is equal to x. So here, what it means that a is a base and x is a power. It's going to be b. Alright, now let's have a look at question. Log base 3 of 36 minus 3 to the power of x is equal to 3 to the power of log base 3 of 2. Now this is just it's nothing. It's 2 equals log base 3 of 36 minus 3 to the power of x. Now we said that how to solve this question. It's easy. We will take base 3 to the power of 2 is equal to 36 minus 3 to the power of x. Now 9 equals 36 minus 3 to the power of x, and 3 to the power of x is equal to 36 minus 9. 3 to the power of x is equal to 27, and x is equal to 3. So that's all. It's the correct answer. Number 16. In number 16, it's given the product of two numbers, each 3 more than the respective roots of the given equation is 34. Find q. So we have equation x squared minus 6x plus q equals 0. Now let's remind about Vieta's formula. When we have ax squared plus bx plus c equals 0, we say that the sum of roots is equal to negative b over a, and the product of roots is equal to c over a. When a is 1, it's more simple. x1 plus x2 equals negative b. x1 multiplied by x2 equals c. Now, since we have a coefficient and that's 1, we are just using this. Now, let's write equation one more time. X squared minus 6x plus q equals 0. Alright, so there are two numbers that each 3 more than the respective roots. What it means, if the first number is x1 plus 3, the second one is going to be x2 plus 3. Now this product is given 34. What we know from the equation, we can say that x1 plus x2 is equal to just 6x1 multiplied by x2 is equal to q. Now we will use this in here. Let's continue writing. Let's expand this brackets. x1 times x2 plus 3x1 plus 3x2 plus 9 is equal to 34. Now, x1 multiplied by x2, it's q itself, plus 3 times, let's take 3 out of the bracket, x1 plus x2 plus, let's move 9 to the other side, it will be 34 minus 9, which is 25. Now, q plus 3 times x1 plus x2 is 6, is 25. Q plus 18 is 25, and q is equal to 7. Correct answer is 7. Number 17. In number 17, we see trigonometry. To solve this question, we need to know the formulas of compound angles. Let's remind those formulas. First was sine alpha plus beta is equal to sine alpha multiplied by cosine beta plus sine beta multiplied by cosine alpha. Next is about cosine alpha plus beta. It's equal to cosine alpha multiplied by cosine beta minus sine alpha multiplied by sine beta. Now, if you compare them with the formulas, which formula should we use? The first formula. Now, as you see, we can write sine, let's rewrite the question. Sine 3 pi over 10 multiplied by cosine pi over 5 plus cosine 3 pi over 10 multiplied by sine pi over 5. Now you see those angles are same, like alpha and beta. Right, how can we write it? We can write sine 3 pi over 10 plus pi over 5. All we need is to add fractions. Now, the common denominator will be 10. We must multiply 5 by 2. 3 pi plus 2 pi is going to be 5 pi. Now, it's sine pi over 2. Pi over 2 is 90 degrees, and sine in 90 degrees is 1. Number 18. In number 18, we are given triangle ABC and A1, B1, C1, which are similar. BD and B1, D1 are angle bisectors. And we also have the ratio of AC to A1, C1 and B1, D1 and all this stuff. Now, first of all, we need to understand what is angle bisector. If B1, D1 is angle bisector of triangle AC, let's show it here. That the line B1, D1 line segment will divide angle B1 into two equal parts. So the same with BD bisector. So BD is a line such that it divides the angle B into equal parts. Then we need to know the property of angle bisector. The ratio of A1 B1 to A1 D1 is equal to the ratio of B1 C1 over D1 C1. It's when B1 D1 is angle bisector. We can write the same to another angle. BA over AD is equal to BC over DC. Let's use let's keep this property because it's same for all the triangles, doesn't matter. Now what is given is they are similar. From the similarity, we should know that there is a scale factor. There is a scale factor that is equal to the ratio of, let's start with AB. AB to A1 B1 is equal to BC to the corresponding side B1 C1 and equal to AC to A1 C1. And also when you have angle bisector, BD over B1 D1. Now, let's write what is given. If AC over A1C1 is K plus 2 and B1 D1 is equal to K and AB is given 12, BD is 8. We need to find A1, B1. Now, we have AB and BD. AC to A1C1. With the help of this ratio, can we write the ratio of BD to B1D1? So BD over B1D1 is the same as AC over A1C1. Now we write K over, BD, which is 8, over K is equal to AC over A1C1 is K plus 2. Now let's solve this equation. We will cross multiply. K squared plus 2K equals 8. K squared plus 2K is minus 8 is equal to 0. Now, with the help of Vieta's rule, we can write K1 multiplied by K2 is equal to negative 8. K1 plus K2 is equal to negative 2. We know that K1 is the solution and K2 is also solution. What two numbers product is negative 8? Either negative 4 and 2 or negative 2 and 4. So in which case the product the sum is negative 2. So we will take this. So K1 cannot be negative 4 because K represents B1 D1. It's the distance. It's not negative. That is going to be positive 2. Now we need to find AB. How to find AB? We can use the ratio AB to A1B1 and the ratio AC to A1C1. AB over A1B1 is equal to AC over A1C1. Now, AB is 12, A1B1 equals AC over A1C1 is K plus 2. It's 2 plus 2. Now 12 over A1 B1 is equal to 4. A1 B1 will be 12 divided by 4, which is 3. The correct answer is 3 here. 19. In number 19, we are given a rectangle ABCD. So let's draw this ABCD rectangle first. AE is a line such that E cuts the side BC. So here is E. And we have another line which is DF that's perpendicular to AE. So it's DF. BE is 3. Let's write 3 here. FD is twice, AB is 4, and FD is twice EC. So let's call EC with X, and FD is going to be twice X. And we need to find the area of rectangle ABCD. First of all, we need to know the formula of area, formula for area of rectangle. So if it is rectangle, we say that area equals A multiplied by B. Now, secondly, we need to figure out the similar triangles. For example, in this picture, we see B is 90 degrees, E and A. So let's find similar triangle to BEA. When we have BC and AD, they are parallel, right? Because it's rectangle. Therefore, if we show this angle with two arcs, that angle is going to be also two arcs. I mean, their degree measures are equal because they are alternate angles. Therefore, the third angle will be automatically equal to the third angle of the second triangle. Now, we can write the similarity. So in order to write the ratio for similarity, first of all, let's write ABE. Start with A and then BE. It's similar to, what's according angle to A? It's D. Triangle D, FA. Now we can write ratios. AB over DF is equal to BE over FA or AF, and is equal to AE over DA or AD, doesn't matter. Now after writing this, we need to know, we can know actually AE. We can find AE with the Pythagoras theorem. I hope you know what's Pythagoras theorem. It's very famous. So c squared, its hypotenuse, is going to be a squared plus b squared. Now we have ae squared equals, ae squared equals 3 squared plus 4 squared. Ae squared is going to be 25 and ae is going to be 5. Now after finding this, let's write the ratios. Alright, AB 4 over df 2x equals BE 3 over AF. AF, let's write AF, we don't know it, and AE over 5 over AD. So AD, we can show AD in terms of x. How? Because BC and AD are equal, we can write AD is also 3 plus x. Now instead of AD, we will write 3 plus x. Now we will take these two ratios and solve it. Before solving it, let's simplify the first ratio. It will be 2 over x is equal to 5 over 3 plus x. Now cross product, 5x is going to be 6 plus 2x, and 3x is equal to 6, x is equal to 2. After finding x, we can say that AD is equal to 3 plus 2, which is 5. Now, what's the area of rectangle ABCD? It's just AB multiplied by 4 multiplied by 5. That's going to be 20. The correct answer is 20. Number 20. In number 20, we are given a shape which consists of circle and triangle. What is given is the length of A and B arc, that is 2 pi, and AC is equal to BC. Let's show it on the picture. OC is 7. Find the area of the given shape. We need to find whole area of the shape. Now, to solve this question, first of all, we need to know the area of triangle. Let's write the area of triangle. It's 1/2 base multiplied by height. And area of circle, this is pi r squared. Also, it's better if you know the length formula of an arc. It's equal to 2 pi r, that's the whole length of the circle, multiplied by alpha out of 360, that's the part of the circle. Now, if we have length, which is 2 pi, we can say that 2 pi is equal to 2 pi r multiplied by alpha over 360 degrees. Now, what is alpha here? That's degree measure of this arc, or a degree measure of this central angle. What is that central angle? That's 180 degree, because in the picture we see that it's a straight line. AB is straight line, therefore alpha is equal to 180 degrees. So 2 pi is equal to 2 pi multiplied by r multiplied by 180 degrees over 360. Now we can cancel those 180 times 2 by 360, and we will get that pi multiplied by r is equal to 2 pi and r is equal to 2. Now after finding r radius, let's denote let's label radius on the picture to make things easy. So it's 2 and 2 here. Now what is the area of the circle? Area of the circle is equal to pi r squared, and that's going to be pi multiplied by 2 squared, which is 4 pi. Okay, let's keep that in mind. Area of triangle is 1/2 of base. So here base is AB. It's going to be 2 plus 2, which is 4, multiplied by height. That's 7. Why it's 7? Because this triangle is isosceles triangle, and the line that comes from the vertex cuts the opposite side into equal parts. It means that CO is median. Because of the isosceles triangle, that's going to be a height at the same time. So that's a height here. We clarified it. Now it's going to be 2 times 7, which is 14. In order to find total area, we need to find the sum of circle, not circle, that's semicircle. So 4 pi divide by 2 plus 14. It's going to be 2 pi plus 14. So the correct answer is 2 pi plus 14. Number 21. In number 21, we see a circle and a second line. What is given is BND arc, degree measure of BND, minus degree measure of EMC arc is equal to 40, and the angle BCD is 70 degrees. So let's show those angles on the picture. BCD is this angle, it's 70. Now, what we need to know here is that the measure of an inscribed angle is half the measure of the intercepted arc. What it means? It means that the angle BCD is 1/2 of the degree measure of BND arc. Therefore, we can write and find degree measure of BND since we have BCD. So it's going to be 1/2 times BND is equal to 70 degrees. From here we can find BND, it's 140 degrees. Now let's show ABC angle with X. So let's label X on the picture. It's X. With the same way, we can say that X is equal to 1/2 of the degree measure of arc EMC. So we don't know what is EMC, but instead of EMC, we can write EMC equals twice X. Now, according to this difference, we can write BND is, what is BND? It's 140, subtract EMC, it's 2X equals 40. Now, it's easy to solve this equation since it's a one variable linear equation. So 2X is going to be 100, X is going to be 50. That's the correct answer. Number 22. In number 22, we are given an isosceles triangle. Before solving this question, let's see what's isosceles triangle. An isosceles triangle is a triangle that has two sides of equal length. So let's say they are equal, and these angles, they are called base angles, they are going to be equal as well. Now, it's better if you know the names of sides. These equal length sides, they are called legs of isosceles triangle, and the one which is not equal, it's base of isosceles triangle. Now, in the question, it says that BDC is an isosceles triangle and BC is a base. So BC is the one which is not equal. BD and DC, they are legs. ABD is 130 degrees. Now we need to find MDC. So that's X. Now we need to know the property of exterior, the sum of exterior angle and interior angle is going to be 180 degrees. Since exterior angle is 130, we will write angle DBC is equal to 180 degrees minus 130 degrees, which is going to be 50. Therefore, the angle C is 50. And then we can find exterior angle x. We can find the other interior angle and subtract it from 180, but instead we need to know the property. I mean, it's not compulsory, but it's better to know the property of exterior angle. It's it's equal to the sum of non-supplementary interior angles. So 50 plus 50, just 100. So the correct answer is 100. Number 23. In number 23, we are given a plane which is square. Now, let's draw it one more time. It's called ABCD, and here is CH perpendicular to the plane. Then, it's given that CH is equal to 8 centimeter, BD is 3 square root of 2, and we need to find DH. So let's connect D and H. We need to find this DH. Now, in order to solve this question, first of all, we need to know it's better to know this shortcut. When we have right angle triangle, if this is isosceles, in our picture we have ABD triangle. That's right angle isosceles triangle because A is right angle. So if this is, I mean, AB and AD, it's square, they're obviously equal. If those legs are equal, we can say that the hypotenuse is going to be square root of 2 times the leg. Therefore, we can say that AB is equal to AD and all the sides are equal. It's just 3. Now, let's write that 3 on DC. Now, what the CH is a perpendicular it means that when a line is perpendicular on a plane, only in this case if it is perpendicular on every line from that plane. Right, CH is perpendicular to the plane. It means that CH will be perpendicular to which line? To CD line. Now we see that this is right angle triangle. We will use Pythagoras theorem here. We will say that 3 squared plus 8 squared is going to be DH squared, and DH is equal to square root of 9 plus 64, and DH is equal to square root of 73. So the correct answer is 73. Number 24. As you see in the question, the functions, quadratic functions are given. They are fx and gx. In which quadrants do the vertices of each function located? First of all, we need to know the formulas of vertices. What are vertices of the quadratic function? Let's say we have parabola, that's vertex of parabola. The x-coordinate is called x0 and y-coordinate we call it with y0. So that's y line. Now, how to find x0? It's negative b over 2a. So let's say we have ax squared plus bx plus c. That's standard form of quadratic function. Now, y0 will be discriminant over negative 4a. By using these formulas, we will find x0 and y0, and then we will discuss in what quadrants do they locate. Are they located? Sorry. Now, let's say for fx, we can write that a is equal to negative 4, b is equal to a, c is equal to 7. Now let's find x0. It's negative b, which is negative 8 over 2 times negative 4, and that's going to be 1. And y0 equals b squared, which is 64, minus 4 times a, negative 4, c 7 over negative 4 times a, which is negative 4. That's going to be 64 minus, here will be plus 4 times 4 is 16 multiplied by 7 over 16. Now we can take 16 out of the bracket. We'll get 4 plus 7 and over 16 it's going to be 11 because 16s will be cancelled. Now for gx, let's write the coefficients. A is negative 2, b is negative 8, and c is 5. So x0 is equal to negative b, which is negative 8 over 2 times negative 2 is equal to 8 over negative 4, it's negative 2. And y0 is going to be a b squared, which is 64 minus 4 times a and c over negative 4 times a, negative 2. Now it's going to be 64 plus 4 times 2 is 8 times 5, 40 over 8. Now this is 104 over 8. We can simplify by 4, we'll get 2, and here 26. 26 over 2 is 13. Now let's show them as points. For fx, we found x0, y0. They are 1 and 11, so the point is 1, 11. For gx, it's negative 2 and 13. Now, in order to define the quadrants, we will understand that 1 and 1, the x coordinate is positive here and y coordinate is positive, so it's going to be in the first quadrant for fx. And for gx, it's negative 2, x is negative, and y is positive, so it's somewhere here. That's second quadrant. For gx, we say that it's second quadrant. The answer is fx, the vertex point of fx is on the first quadrant and the vertex of gx is on the second quadrant. Number 25. Here we see a diagram that shows the number of students in classes A, B, and C. If the percentages of the number of boys in classes A, B, C to the number of all students in 3 classes is M, N, and K respectively, we need to find M plus N minus K. So first of all, we need to collect the information from the graph. Look at the graph. In class A, there are the number of boys is 10 and the number of girls is 6. Now the total will be 10 plus 6, which is 16. Now in class B, there are how many boys? 8 and girls are 2. Now total will be 8 plus 2 is equal to 10. In class C, the number of boys, they are 10 and the girls, oh sorry, that's not 10 boys, are the white rectangle, 4. That's 4 girls, it's 10. Now total will be 4 plus 10. What the question says, we need to find M and K first and then find this expression. Now what is M? Before finding M, we need to find the total students, number of total students in 3 classes. The total will be 16 plus 10 plus 14. So that's 14, it's 10. It's going to be 40. Now, after this, we need to find M. This is the percentage of boys in class A, which is 10 over to the all students. Total is 40. And percentage means we must multiply this fraction by 100. Now, N is the boys in class B, 8 over the total multiplied by 100%, and K will be in class C, there are 4 boys and 4 over 40 multiplied by 100%. So it's going to be 1 over 4 times 100 is 25%, is going to be 20%, and that is 10%. Now we need to find M plus N plus minus K, which is 25 plus 20 minus 10. So it's going to be 40 minus 10, it's 35. So the correct answer is 35.